those of you that don't know me, you might be wondering why the introduction introduced me as Jerry, but over there it says Gergana. That's because I kind of have two names. Gergana is my real name. It's a Bulgarian name, and it only gets used in the tiny country that I come from. And that's why it gets mispronounced very often. That used to irritate me, but it's gotten to a point where it's been mispronounced so many times that I'm no longer sure I'm pronouncing it correctly. So that's why I go by Jerry. I have been a web developer pretty much since I started working. I started off in ASP.NET and C#, but even when I worked with that, my love for JavaScript was always there. Started off with jQuery, where I used to make things appear on the screen and things like that, and it has evolved to the point where I'm building full-scale web applications and controlling robots with JavaScript. I started at BBD 4 years ago, and I've been at APSA ever since, until today. Tomorrow is my first official day at ATC. Now, I don't really know what ATC stands for, and I don't really know what ATC does, but hopefully next year I'll be able to tell you. Before we get to the actual presentation, two quick disclaimers. First of all, for those people who saw my talk last year, I'm really sorry, but the T in AOT does not stand for things, so there's no cute robots this year. And the second disclaimer is for those of you who saw my talk at JSNSA, I'm sorry, but this talk is very similar, so I really hope you don't get bored. But I'll try to keep it interesting. So a few quick questions. Are there any Angular developers in the room? You've seen some Angular code before? Okay, cool. There's a few people who know what I'm talking about. I'm glad. What about other JavaScript libraries? Ember, React, Vue? Any of you guys? Cool. Well, I'm sorry to say, but as far as I know, AOT has absolutely no applications to these libraries. But that's as far as I know, so do some research. What about backend developers? C#, Java, Ruby, Python? Okay. I have two things to say to you guys. The first one was stolen from Mike, and life's too short for static typing. And secondly, any application that can be written in JavaScript will eventually be written in JavaScript. This is Atwood's law, but I guess you guys are in this room, so you're already in the right direction. So let's get started. What is Angular? Well, it was initially released in 2010, and it became the best thing since the original ASP. Very quickly gained popularity, everyone was using Angular. By the time I started using it in 2014, it was one of the most popular UI frameworks out there. Then they announced Angular 2. Angular 2 was going to be better, it was going to be faster, it was going to be the new best thing since ASP. But there would be no upgrade path from Angular 1 to Angular 2. So the development world went berserk. They had just finished all their amazing applications using Angular, and now they would have to rewrite all of them. But then, by the time it was officially released in 2016, they had formulated an upgrade path. It wasn't a very simple upgrade path, but it existed. Then, 2 months later, they announced Angular 4. And the development world went berserk. First of all, what happened to 3? And we just started upgrading 1 to 2. Now we're going to have to convince our clients that we need to upgrade 2 to 4. Well, it's not that bad. They now decided that they need to use versioning standards called semantic versioning, And that just means that if they make a big change to the framework, something that might break your code when they release it, they would up the first number, that's the major number. If they made a smaller change, something that wouldn't break your code, that would be the minor number. And if they just fixed the bug, they would upgrade the last number. That would be a patch. But now, the other thing that was quite confusing was you can't call it Angular 2 anymore, it's now 4. So they decided that everything that was Angular 1 would now be referred to as AngularJS, and everything from 2 onwards would now be referred to as Angular. I know that's not confusing at all, right? So, AOT. AOT stands for ahead of time, and it's usually followed by the word compilation. And ahead of time compilation is an act of compiling higher level programming languages into machine code so they can run natively on a computer. Now, to those of you that know, probably most of you, Angular is a JavaScript framework. So you're probably wondering, JavaScript is not a higher level programming language. It does not need to be compiled, and it does not need to run natively on a computer. So what on earth am I talking about? Well, Angular does need compilation. And the reason Angular needs compilation is for achieving a higher level of efficiency in the Angular applications. So Angular has declarative bindings on views and decorators on modules. And all of those things need to be compiled to a native JavaScript that can run inside a browser. So it's not true compilation like the definition of compilation, but it is taking your decorated TypeScript and compiling it down into a JavaScript that can be understood by the browser. But it's not just because of TypeScript that we needed compilation in Angular. Because in AngularJS, which does not use TypeScript, we also needed compilation. This is an AngularJS directive, and at the bottom there is a template that displays this directive. But that is not standard HTML. If you put that into the browser without any JavaScript, it would not know what to display. So the class above it is the JavaScript that actually gets compiled into something that is understandable by the browser, and that's how your code actually gets displayed. But one of the biggest downfalls of AngularJS was its compiler. It had a very dynamic approach to both rendering and change detection, and the compiler was quite generic. So it would work for any template by performing a set of dynamic computations. But the JavaScript virtual machine struggles with optimizing the calculations because they're so dynamic. And since the virtual machine doesn't know the shapes of the objects which provide context for the dirty checking logic, its inline caches get a lot of misses, and this slows the execution down. In Angular 2, we have components. You can see the template of the Angular 2 component looks very similar to the one of AngularJS. And above it is the TypeScript definition of that component. Instead of using the same dynamic style for rendering and change detection that AngularJS uses, the Angular framework generates virtual machine-friendly code, either at runtime or at build time. And this allows the JavaScript virtual machine to perform property access caching and execute the change detection and the rendering all a lot faster. And that's what made Angular a lot faster than AngularJS. As I said, this can be done either at runtime or at build time. When we do it at runtime, we call it just-in-time compilation. And the way that works is it takes your TypeScript, the TypeScript compiler compiles it down to JavaScript, and then that happens at build time, and then that JavaScript gets sent to your browser, and the Angular compiler compiles that JavaScript into browser understandable native JavaScript. So that runs every single time for every user, and every time refresh is hit, the work must be redone. So you can see how this might slow things down a little bit. On the other hand, we can also do it at build time, and this is what ahead of time compilation is. In this case, the Angular compiler does everything. It takes the TypeScript, compiles it down to the plain native JavaScript that needs to run in the browser. And it does this at build time during the build process. So it only ever runs once. This does, however, slow your build process down a little bit. It's built into the Angular CLI build process, and it's going to be a standard in Angular 5, as far as I know, which is supposed to be released next month. Some of the benefits of AOT. First and foremost, performance. We live in a world of millennials, social media, and instant gratification. So performance is important, especially when it comes to websites. Then there's build time errors. For you statically typed guys, you get your errors at build time instead of at runtime, because everything happens in the build process. There's energy efficiency, which is a little bit of a controversial one, but what they mean by that is because your user's device is no longer doing compilation, it can save some battery and some bandwidth. And then there's also better security. By that, they mean that when you compile your Angular, you minify it, and you ship that to production, that makes your app a little bit more secure, because it's more difficult to access the code that you're deploying. And lastly, size. Size can be split into 3 different sections. Firstly, tree shaking. This is a feature of Webpack, and what a tree shaker does is it walks the dependency graph from top to bottom, and it shakes out the used code, the unused code, like dead leaves in a tree. So with small Angular applications, one of the biggest benefits comes from excluding Angular features which are not being used. Then there's minification. So when you minify an application with just-in-time compilation, you can't minify it completely. So the properties usually get minified to single letters. But when you have JavaScript that's being referenced by your HTML, and the HTML doesn't get minified, then those properties can't be renamed because the HTML template won't know where to find the properties anymore. So just-in-time compilation produces slightly larger minified files. With ahead-of-time compilation, all the HTML and CSS gets inlined into the component's JavaScript. So when it gets minified, the full file gets minified, and therefore you get a truly minified file. And the last reason for the size is the compiler. So now you no longer need to ship the compiler with your production code, so that reduces the size of your application because you've already compiled all of your code. There are a few things that need to be considered when you use AOT. Firstly, public properties and exporting functions. The Angular compiler generates TypeScript files for dirty checking algorithms. And since TypeScript has access modifiers and enforces access only to public properties outside the inheritance chain, it would not be possible to access any private properties or functions that have not been exported. And then the other one is external libraries. If you're using any external libraries that have not been compiled with AOT, you will not be able to compile them into your code with AOT. They need to have been shipped with a metadata.json file. I was saying earlier that the build process now takes longer. And because of that, they suggest that it's better to do your development in just-in-time compilation and only when you go to production, you go to ahead of time compilation. So in order to do that, you'd have to make some changes to your code. If you're not using the Angular CLI, there's a few things you need to change. The first one is the main.ts file. The top one here is one for JIT, and the bottom one is one for AOT. There are two major differences. The first is the platform browser dynamic versus the platform browser. The dynamic part really means that you plan to deliver raw code, so Angular has to deliver the compiler. So by putting platform browser without dynamic, the compiler doesn't get shipped to production. And the app module ng factory is the other difference. So this file is the output of the ahead of time compilation process. It's an executable form of the app module. And it contains things like compiled bindings and templates and other Angular logic that you don't normally get to see. The next thing you'd have to change is your TypeScript config. You'd have to include this into your TypeScript config. This pretty much tells it that you're compiling with AOT, so the Angular compiler is going to do everything. And then the last thing you need to change is your Webpack config. Your Webpack config, by default, includes all HTML and CSS into the build. But by including this, you're going to tell it to not include those, because Angular inlines all of that already, so this would reduce the size of your application a little bit. So, in other words, if you wanted to develop it with JIT and build for production with AOT, you need to first create a main.ts file, then create a new tsconfig file, then add scripts to your packages.json so that it builds differently for development and production. Change the entry point of your production build so that it references the new main.ts, and change your Webpack config. That's quite a lot of work. Instead, you can use the Angular CLI. In order to use the Angular CLI, you have to install the Angular CLI. You have to create a new project using the Angular CLI, and then build your project in production mode. That's it. The only difference, if you don't want to build with AOT for production, is you'd have to add a --AOT equals false. Another benefit of using the Angular CLI is that you know what environment you're running in. And because you know what environment you're running in, you can enable prod mode when running in production. And what enable prod mode does is, by default, Angular runs a second change detection cycle after each main one. This checks to see if anything changed after it should have, and notifies you of a bug if a change is detected. By enabling prod mode, the second run is disabled, and that improves the performance. So over here, I've created a little example application. I use the Angular CLI because, as I mentioned, it's a lot easier. And there's a few things I want to show you. Firstly, when using the Angular CLI, you don't really have control of the Webpack config unless you eject the Webpack config. And configuring Webpack is actually really difficult. So it's better to not eject the Webpack config for as long as possible. The other file I wanted to show you is the tsconfig. So I spoke about those things that need to be added if you're not using the CLI. But because we're using it, we don't need to add that stuff. The Angular CLI knows how to build your TypeScript without that stuff added in. And because we're using Webpack, we have tree shaking. So I've created a little service over here called the tree shake service, and it just returns a string. I'm going to include this service into my application and show you how, when I build, it exists in the build code. So first I have to include it in the main module. Then I have to include it into my component. And then I have to actually use it. So all I'm doing is logging that string. If we build this now, no, that's not how you spell build. So this build process will usually take a bit longer. This is a very small application, so it won't take that long. But with bigger applications, because it's using AOT, it takes quite a while. Once built, we can go into the main file over here. Come on. And search for tree. So there is that method that calls for that little string. Now, if we undo this and exclude the tree shaking service again, and build again, I needed to build for production, not just build. There we go. Now, if we search inside the main file for tree, it doesn't exist. So that's what tree shaking does. It takes out all of the dead code. Now, let me show you what this app actually does. I'm just going to start it up. So this app was made to help you find the droids you're looking for. By answering a few questions, you get to find the droids you're looking for. Not all the answers are BB-8, although they should be. We do have some other droids in here too. I will share my GitHub account with you guys later, if you too would like to find the droids you're looking for. Cool. A mistake that people usually make is to think that when using this Angular CLI, they can just type ng-build. And that does work. It is building, it is going to produce files, but these files are rather large. It builds a lot faster, but you can see in here we have quite a few megs. I think it's about 5 or 6 megs of files. Wow, that's terrible. You can't see. Should have sat on that side. Sorry, guys. Okay, but yes, there's quite large files. And this includes the JavaScript mapping files. The cache's not broken, these files aren't minified. That's why it's so large. So what you're actually supposed to do is build for production. But first I want to show you a build for production with AOT disabled. So this build will take a little bit longer than the one that was not for production, because it will break the cache and minify the files. But it still shouldn't take as long as the one where you use AOT. And we have same folder and same files. Well, all the mapping files are now gone, and everything has been minified, so a lot smaller. And then lastly, if we build with AOT, this takes a little bit longer. We have, again, same files, minified, and slightly smaller. I'll show you in my slides how much smaller they actually are. Then the other thing I spoke about was the build time errors. So if I change this field to private, and I try to build with AOT, it will fail and give me a build time error. If I built without AOT, the error would only appear once I open my browser. There we go. And the error says, they're pretty good errors. It tells you exactly what controller, what field, what you've done wrong. So the actual file sizes that you probably couldn't see. Most of the file sizes are kind of similar. There's two that I want to talk about. The first one is the main file. The main JavaScript file is 20 kilobytes with AOT and 8 kilobytes with JIT. When I first saw this, I thought my entire talk was a farce, because I'm talking about how it improves size, and this is clearly not improved, it's gotten worse. But I read more about AOT, and I watched a whole lot more videos, and yeah, so I figured out that the reason for this is because the JavaScript that gets compiled with AOT creates larger templates than the normal HTML templates that you get when you send to the browser just standard HTML and JavaScript. And the Angular team is working on improving this, and we can trust them because they work for Google, right? But the other file that's a lot more interesting is the vendor file. So with AOT, it's 400 kilobytes. With JIT, it's 770 kilobytes. Now, that's quite a large difference. And the reason for this is because the compiler is not there with AOT, and the tree shaking and all that wonderful stuff. So that difference is a lot more significant than the 10 kilobytes of the main file. So our app will be smaller with AOT. The other performance comparison, we have the time. Most of those files took about the same time to load. That is because the application I have is quite small and not very in-depth, so it's not actually a very good comparison for when comparing times. But if you have a look at the vendor file, with AOT it took 36 milliseconds, while with JIT it took 291 milliseconds. That is almost 10 times faster. And that is because the compilation is no longer happening in your browser. So when you're building larger apps, this performance would improve even more. As I said, my GitHub repo, all of the references to all of the stuff I talked about, you can find in there. And I think they're going to share these slides, so don't worry about not being able to remember some random letters. Cool. Thank you.